right, so again, you guys on your own last night did addition, subtraction, and scalar multiplication, so I can just blow right through those parts and jump right to the multiplication part. Bless you, which is really the more difficult part. Also, make sure, don't put this in your notes, just look here. The only time you can add and subtract matrices is when they have the same dimensions. Do those two matrices have the same dimensions? No. So you can't, you're not able to subtract them. Because you have a 2 by 2 and you have a 2 by 1, which can't happen. All right, so we did scalar multiplication, so now let's do actual matrix multiplication itself. All right, so the only time that you can multiply matrices together is if the following holds true. So if we say matrix A has the dimensions m by n, whatever numbers those would be, and B has the dimensions n by r, because, remember row by column, because my column of the first is the same number as the row of the second, then I'm going to be able to multiply those together. And your resulting dimensions of the product of those two are going to be the row number of your first and your column number of your second. So you can only multiply matrices if the number of the columns of the first is the same as the number of rows in the second. You might want to write that down. Okay. So again, your column of the first needs to match up with the rows of the second. I always usually get in the habit of writing out the actual dimensions of the two matrices that are given to me so I can physically see if the two numbers in the middle are the same. And the beauty of our graphing calculators is they'll do all of this stuff for us, so you can always check your work to make sure you're doing things correctly. Isn't that nice? All right, so everybody good? Okay, so let's start with two matrices. We got H, which is 2, -3, 1, 5. And then G, which is 6, 0. 4, 7. Okay. So we're going to find HG, and they're always going to say if it exists, because maybe it doesn't exist. So what I personally like to do is just to check to make sure I can multiply is I write the dimensions down. So this has how many rows? 2 by 2 columns, so that's a 2 by 2. G is a 2 by 2. Do my middle two numbers match up? Yes, meaning does my column of the first match up with the row of the second? Yes. So then my resulting matrix is going to be whatever is my row in the first combined with whatever my column is in the second. So my product of HG should end up being a 2 by 2. And the reason why I want to focus on that is because when I make my matrix of my product, I want to have 4 blanks for my 2 by 2. Okay. So row by column is always kind of the theory here. Do you guys remember doing this last year, matrix multiplication? Does anyone remember what to do? Kyle?
Wasn't it take the column of 1 and multiply it by the row of another?
Yes, but you would do row with the column, right? So to find element A11, so row 1, column 1, I'm going to combine my row 1 with my column 1, right? And we're going to make a product, but we're also going to be doing a sum. So I'm going to take this number 2, and I'm going to multiply it by 6. So 2 times 6, and then I'm going to add to that product, I'm going to match up -3 with the 4. So -3 times 4. And this will come together and make some number. Well, 2 times 6 is 12. -3 times 4 is -12, so that's going to end up being 0. So write a little 0 above it. Sorry, am I in your way? Can you see?
Yeah.
Okay. Okay, so that was row 1, column 1. What do you think you're going to do for row 1, column 2? Combine row 1 with column 2. So I'm going to erase that. And I'm going to combine my row 1 with my column 2. So I get 2 times 0 plus -3 times 7, which will result in -21. So I'm just going to write that a little bit above. Now I want element row 2, column 1. So that means I'm going to use row 2 of my first and combine it with column 1 of my second. So what's that going to look like? 1 times 6 plus 5 times 4, which, like Kyle said, is 26. What's the last one going to be? 1 times 0 plus 5 times 7, which is 35. So notice that your row numbers are consistent. Like my row of my first is 2, -3, 2, -3, 1, 5, 1, 5. And then my columns for the first, 6, 4, 6, 4, are together in a column. 0, 7, 0, 7 are together in a column. So my final answer, so let's rewrite it as one matrice, is going to be, so I would write, can I erase this? Is that okay? So HG is equal to, oh, now I don't even remember what the numbers were. What's the first element?
0.
0.
-21.
-21, 26, and 35. Thank you. There's our answer. Okay. So, can you do GH on your own? So do G times H. Try it out. So G is going to be first. H. If you need to, like me personally, I would rewrite it so that my H is after. So then I know I'm doing row, column, row, column, row, column, row, column. But maybe you could do it without having to do that. So the beauty of these calculators is they do so much stuff that you're not even aware of all the stuff that it does. Now again, I'm only showing this to you so that you can check that you are doing things correctly. Does that mean that you just have your calculator do it for you? No. I'm going to expect you to show me the numbers that you were multiplying plus the numbers that you were multiplying for each of your spots. Okay? I'm only showing this to you so that you can use it to check what you are doing. So, does everybody see right here at the x to the -1 the word matrix in the second area? So go ahead and hit second and then that button to enter the matrix mode.
What if it says finance? Is that the same thing?
should not say finance.
Okay.
All right, so now I have matrices already in mine. Yours might be blank. Are yours blank, or do you have stuff in here? All right, that's okay if you do. The first thing you have to remember to do is make sure you edit your matrices. So scroll over to the edit, and let's go ahead and edit matrix A. So hit enter. Now you get to decide what the dimensions are of your new matrix. So we just did a 2 by 2, so I'm going to turn mine into a 2 by 2. Okay. And then let's input what was H. I forget what H was. What are the dimensions? It was 2,
-3, 1, 5.
so I'm going to type in 2, -3. Make sure you use the negative button for your negative, not the subtraction button. Those are two different things. -3, 1, 5. Then we're going to have to go put G, so go back into that matrix screen, over to edit. Let's edit B, so number 2. Turn that into a 2 by 2. All my stat stuff in here, and that was, oops, 6, 0, 4, 7. Okay, so we've got those two matrices inputted in there. So now when we go back to our matrix screen, I want to, so notice these now changed, 2 by 2, 2 by 2s. So I now want to select H, which we put in as A. I guess I could technically have put it in for H, but that's okay. I want to figure out what A times B is, which was our H times B. So I'm going to select A. Oops, why is it go? Maybe I have to quit out of there. Second quit out. I don't know why it makes it keep editing. You select A. There we go. Get to that home screen. Is everybody okay? And I'm going to hit times, and then I'm going to go back into matrix and select B, which is number 2. And I'll hit enter, and voila. Isn't that what we got for our first answer? 0, -21, 26, 35. I could do B times A. B times A.
How do you know how to do all this on a calculator off the top of your head? Because this is so hard.
It's just years of using calculators. Maddie?
Is there another way to get into it? Because I just, like, it's a graph calculator, I don't know.
Oh yeah, yours doesn't say matrix. This one must not have a matrix. It's an older version.
Yeah, it was my dad's.
Yeah.
Yeah, that's ancient.
Yeah. All right. It could do A plus B. It could do A minus B if you want it to. Okay? So, calculator does matrices for you, which is also going to do a whole lot of other stuff for us when we continue on in the matrices worlds and we talk about identities and inverses of them. All right, so let's jump back to our notes. Again, I'm only showing this to you so that you can use it to check your work, not just put the answer down and hope you get credit for it, because that's not going to happen. All right, let's get a new HG up on our notes. So now HG is a row by column, so 2 by 3 with 3, 6, 1, -1, 0, 2. G is 2, 5, 0, 1.
My question is H 3 by 2 or 2
Row
by 3?
by column. RC. So this is a 2 by 3. So we got a 2 by 3, and we're multiplying it by a 2 by 2. Do my two middle numbers match up?
Nope.
Nope. So can I multiply HG?
Nope.
Nope. Can not multiply, or does not exist, whatever you want to say. Well, then we're going to do the opposite. We're going to see if we can do GH. Would GH exist? So if I do GH instead of HG, that means my G was a 2 by 2 being multiplied by a 2 by 3. Can that be multiplied? Yes. What will be the resulting dimensions? It will result in a 2 by 3. So, and the reason why I care about that is when I go ahead and make my big matrix here,
So, the two.
I know I'm going to have 2 rows, 3 columns.
We know that because the two numbers on the outside of that
Right.
are
Yep.
2 and 3.
So it comes from this. Okay. So now let's take care of element 1, 1. So row 1, column 1. Keep in mind G is first. So G is first. Me personally, I need to be visually able to see it in order, so I'm going to rewrite my H right after my G. Just transfer it over there. Okay, so row 1 compared with column 1. What's that going to look like? 2 times 3 plus 5 times -1, which will get us 6 and a -5, so +1. Okay. Row 1, column 2. Let's see, it means I'm using my row 1 from the first, column 2. So 2 times 6.
It's just 12.
Yep, plus 5 times 0, so just 12. Good. So for you to get full credit, I need to see this work right here.
Oh, jeez.
Row 1, column 3, 2 times 1 plus 5 times 2, which would also be 12. 10 plus 2. Row 2, column 1, so row 2, column 1, so 0 times 3 plus 1 times -1, so -1. Row 2, column 2, so row 2, column 2, 0 times 6 and 1 times 0 is going to be 0. I guess I should have done 0 times 6 when I wrote it. That's okay. And then row 2, column 3, 0 times 1 plus 1 times 2, so 2. So then write your final answer as just a simple matrix. I'll put it up here in the top right corner. So we ended up with, it looks like 1, 12, 12, -1, 0, 2. Okay. So you have to check your dimensions first to make sure that it does work. When they do match up, then your new dimensions of your product will come from the beginning and the last. All right. All right, the last thing we have to cover is there are word problems. I think there's 2 of them in your homework tonight with setting up matrices given a word problem. So let's go ahead and I would just copy down this table. So here we have student council is selling flowers for Mother's Day. That's nice of them. They bought 200 roses, 150 daffodils, 100 orchids. And the purchase prices are shown. And then they sold the flowers for the sales price shown. So we need to organize the data into 2 matrices, use matrix multiplication to find the total amount that they spent on the flowers. All right, so they've got a rose. Purchase price was $1.67. They sold them for $3. Daffodil was $1.03. Sales price was $2.25. Orchid was $2.59. They sold it for $4.50. And then I would just write off to the side that they bought 200 roses. So I would just put a little 200 here next to the roses. They bought 150 daffodils and 100 orchids. All right, so we want to create two specific matrices and then use matrix multiplication to find the total amount that was spent on the flowers. So what do you think we can do? How would you just figure it out in general? What would you do? Just talk it out. If I wanted to figure out how much they spent in total on flowers.
Multiply the purchase price by the number of whatever flower you bought.
Right.
And that'll put together.
Right. Wouldn't that be it? Just if I paid $1.67 for 200 roses, how much would that be total? I paid $1.03 for 150 daffodils. How much would that be total? $2.59 times 100. How would that be total? Right. So, what things am I multiplying together?
The number of flowers in their purchase.
And the purchase price. So we need to make two matrices with that. So let's go ahead and make a purchase price matrix. So I'm going to make it a 3 by 1. So 167, 1.03, 2.59. That's a matrix. Now that's a 3 by 1 matrix, which means my second matrix should be how many rows? 1, and since I have 3 things, it's going to be a 1 by 3, right? So turn this data into a 1 by 3 matrix. So 1 row, so 20 or 200, 150, 100. All right, 1 by 3. Okay, so how do we multiply that? It's going to end up in a what? 3 by 3, right? Okay, so I'm running out of space here. 3 by 3. Which just won't be that hard because I don't have too many things to add. So row 1, column 1 means I'm going to do row 1 times column 1. Well, does this make sense though? Maybe we should have done it the other way around.
No, I think this makes sense.
Yeah, but then I'm going to be taking 150 times 1.67.
You're right, yeah, and you multiply 200 by 103. Yeah, they need to be flipped.
They need to be flipped, don't they?
Yeah.
All right, cross that out. We need to flip it. It's good we thought about that. So it should be 200, 150, 100 times 1.67, 1.03, and 2.59. But then we're still multiplying the 103 by 200. Now I'm confusing myself. We need it to end up being a 1 by 1, right? So this is good. We're thinking about this stuff. Nevin looks so angry at me right now.
I'm using a pen right now and going back and forth.
Not working for you? All right, let's think about this. I need my result to be, this is good. Don't I want a 1 by 1 to be my final result? And I've got 3 things. So what should my dimensions be?
Do a 1 by 3 and a 1 by, I mean, sorry.
A 3 by,
4 by 3 and a 3 by 1.
a 3 by 1 times a
4 by 3.
1 by 3. And then, no, that would still be a 3 by 3. Yeah, say it again. I need a 1 by 1.
1 by 3.
And a 3 by 1 would get me a 1 by 1, right? Okay, so let's redo that. So a 1 by 3. I should have just put the other ones in first. Which one do we want the 1 by 3 to be?
Price. Number. Yeah.
200, 150, 100 times, what are you whispering over there, Kayla? So that's a 1 by 3, so now we're going to do a 3 by 1, which I guess all I need to do is just put my other thing in front of the other one, huh?
Oh, yeah.
You could have just drew an arrow, Nevin. This is all part of the learning process. Okay, so now multiply it out. So we're going to do 200 times 1.67. I don't know what that is. 200 times 1.67, which is 334, plus 150 times 1.03. Oops, why did I add a parenthesis in there? Which is 154.5, plus 100 times 259, which is 259. So 334 plus 154.5 plus 259 is 747.5. Okay. But come on, that's good, because now you guys won't make that mistake, right?
Yeah, no, you're right.
You gotta think about what you want in the end. So we could do the same thing then for sales price, right? Put the sales price in here instead, see how much we make, and then we could figure out the profit by subtracting the two. Okay. Did we really need to do matrices to do that? Probably not. You probably would have just done it by doing your multiplication. All right, so for your homework, you are doing